Okay, so the next video is on the electromagnetic spectrum. So first of all, the electromagnetic spectrum are a particular type of wave, electromagnetic waves. And basically they're called electromagnetic waves because it's essentially an oscillation or propagation of the electric and magnetic fields. Okay, so we have like the electric fields and the magnetic fields being oscillated. Now they actually oscillate at 90 degrees, the direction of the wave. Okay, so if you have the direction of the wave moving like this, they're oscillating perpendicularly to the direction of the energy that's being transferred in this case. So this makes it a type of transverse wave. Okay, so we have it being a transverse wave. The other thing is because it's an oscillation of an electric and magnetic field, it doesn't require any particles. Okay, so a lot of people get a little bit confused because they think it's particles moving. It's actually the field that is moving. So it doesn't actually require any matter. Okay, so no matter is required. And also that means that it can travel inside of a vacuum. Okay, so if it does not require particles, no matter, it can travel inside a vacuum. And when it travels inside the vacuum, it travels at the speed of 3 × 10⁸ meters per second, okay, is the speed in a vacuum. Okay, so these are what we call the properties of electromagnetic waves, and it's really good to make sure that you've got those written down, that you know those, as they have asked those questions in the past. The next little bit then is explaining what is the electromagnetic spectrum. Okay, so in this case we want to talk about the types of waves that there are. So we have, okay, I'm just going to leave her there. We have radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Okay, now these are all the types of waves. I've put them in this order, but the exam could ask you to be putting them in the opposite order. Okay, it's better than knowing kind of which ones are placed by which. I've put them in this situation from being, I'm just going to move you, from being the longest wavelength to the shortest wavelength. Okay, so in this case, going from a long wavelength to a short wavelength, okay, or going from a low frequency to a high frequency. All right, I could have also wrote them the opposite way round. All right, visible light as well is also made up of different colours, so we also know that's red, orange, yellow, green, blue, indigo and violet. Now, each of these you have to learn, and it's one of those ones actually for physics. We don't have it very often. We have to just memorise the wavelengths, okay? So in this terms, we're going to talk about the wavelength for radio waves, okay? So in this case, that's about 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ for radio waves. Right, for microwaves, it's around about the 10 to the 3, sorry. For microwaves, it's around about the 10 to the minus 2 to 10 to the minus 3 meters. For infrared, it's about 10 to the minus 4 to 10 to the minus 6 meters. Visible light is very specific, okay? We say it's 700 to 420 nanometers. All right, ultraviolet is 10 to the minus 7 to 10 to the minus 8 meters. X-rays, okay, 10 to the minus 9 to 10 to the minus 11 meters. And then for gamma, 10 to the minus 12 to 10 to the minus 15. Okay, so again, you can see that the wavelength is getting shorter, and just be really careful. I made a little mistake up there. That is 10 to the 3, all right? So each of these you have to learn, and the way that they ask this in the IB is they ask you sometimes like, Nate, tell me what type of wave this is, or they might give you a wavelength in a multiple choice question and say identify the type of wave. So again, if you see something with like 10 to the minus 8, you're going to know it's an ultraviolet wave. Sorry. Now, if they also know the wavelengths, you actually also know the frequency of these waves as well, because we can use our wave speed equation. So V is equal to F lambda. Well, in this case for transverse waves, we should actually be saying that C is equal to F lambda, because they can travel at 3 times 10 to the 8 meters per second in a vacuum. So often we use that for our C value. If they don't give you a value for the transverse wave, that is the value that you're going to be using. Okay, so something where sometimes students think they've not been given information in a question, but you really have, because you've been told what type of wave it is. So again, if I wanted to work out the frequency of these waves, I could just do C divided by lambda. Remember, frequency is measured in hertz. Our speed is measured in meters per second, and our wavelengths are measured in meters. So just make sure that you've got them being converted into meters, because sometimes they might give you like nanometers or micrometers instead. So just checking that you've put it into the meter format for this. And that is the electromagnetic spectrum.